Hello, everybody. How's it going today? Testing, testing. Hopefully this test works out. Yeah. 20 people in today. That's good. Ooh, I should put the slides up on Avenue, shouldn't I? I should probably do that, yeah. Hi. I'm not going to say anything about the stream or the reliability of the stream in order that I might not jinx it. So, yes, I am a Beethoven fan. I like Beethoven. Bach is good. Beethoven is my favorite, though. Might as well get right into it. Today we're going to be introducing C++. C++ is a fun language, by which I mean it is a difficult language with a lot of nuances to it. However, our studying of C up to this point hopefully will provide us enough background that we can get into C++, with as little pain as possible. I don't mean to make it sound like C++ is like this horrible, painful language, but a lot of people have that impression of it. So, boop, boop, boop. Cool. So, the C modernization project. I have this comic. Days 1 to 10. Teach yourself variables, constants, arrays, strings, expressions, statements, and functions. 11 to 21. Teach yourself program flow, pointers, references, classes, objects, inheritance, and polymorphism. Days 22 to 697. Do a lot of recreational programming. Have fun hacking, but remember to learn from your mistakes. Day 698 to 3648. Interact with other programmers. Work on programming projects together. Learn from them. Day 3649 to 7781. Teach yourself advanced theoretical physics and formulate a consistent theorem of quantum gravity. Days 7782 to 14611. Teach yourself biochemistry, molecular biology, genetics. Day 14611. Use knowledge of biology to make age-reversing potion. Also, day 14611. Use knowledge of physics to build a flux capacitor to go back in time to day 21. Day 21. Replace younger self. As far as I know, this is the easiest way to teach yourself C++ in 21 days. So, the C modernization project. The original designers of C did not expect the language to become so popular so quickly. It sort of exploded in popularity in the 70s. C quickly became entrenched, and only so much could be... Maybe it's my phone that's doing this. Testing, testing, 1, 2, 3, testing, testing. Hello? Are we back? Testing? Ah, yes. Okay. Alright. So, like, how much did I lose there? So, okay. Alright, let's try this again, folks. Let's try this again. So, C quickly became entrenched, and only so much could be changed to maintain back compatibility. In 1979, Bjarne Stroustrup began developing C with classes at Bell Laboratories. By 1985, this project had become C++. The ++ is a reference to the increment operator in C, indicating C++ as the new and improved C. The design philosophy of C++ was to take C, the language, and integrate more abstract language features to make it less of a pain to write and maintain large programs. To be properly studied, C++ would require its own course, where, like, obviously, since C is such a large and well-supported language, and a popular language that's still very much in active use today, to consider yourself to be a C++ programmer, you're going to have to do a lot more investigation into it than the last 2 weeks of this course will be able to provide you. I don't want to see anybody putting on their resume that they know how to program C++ after having seen these slides, for example. Same thing with ARM assembly. You guys don't get to put ARM assembly on your resume just because you did 1 week of it in this class. So, yeah, anyway, got some questions. I ended up deciding to cancel the midterm, yeah. So, yeah, there's just no time to have a second midterm, so. Yep, there is going to be a 5th assignment, though. Hopefully that'll be released on Monday. It's going to have structures, data structures type material on it, and some of the assembly stuff on it as well. Cool. Stream still good? Stream still good. My goodness. Okay. So, for any of you who I think I remember showing you guys this graph at the beginning of the semester, just to show you that C is currently the world's most popular programming language. At the moment, C++, which is this line in orange, is the world's 4th most popular programming language. It goes C, Java, Python, and then C++. You can see that it's sort of, if you go backwards in time, C++ was, much more highly rated, sort of around the same vicinity that Java is now, but over time, various languages have sort of risen and fallen, and, in particular, C# has, over time, managed to grab a reasonable chunk of C++'s market share, as you might expect, considering C# is hypothetically the successor language to C++. So, yeah, and also, Python has tore its chunk off of C++'s dominance as well. But the thing to keep in mind is that the fact that C++ was a dominant language historically, that's still important, because if you actually want to do a job that's working with programming languages, you'll find that a lot of the existing code base is going to be written in the languages that were popular, say, a decade ago or 2 decades ago. So learning C++ is definitely still a very much irrelevant skill in today's modern society. When might A5 roughly be due, then? Let's see. What's the latest I can make it due? I think the last day of classes is, in this vicinity, so probably we'll have it as the 6th of December. I have to look at the rules again to see if I'm allowed to have an assignment deadline that close to the exam period, but yeah, something like that. You'll have at least a week to work on it. Let's put it that way. Cool. Right. So, let's get into it. How is C++, how does that compare to all of the work that we've been doing in C so far? Because, given that C++ is developed directly from C, one might expect a certain degree of cohesion between the two. Pretty sure other classes have stuff due that late. Again, I have to do things by the book, so I'll there's a restriction. If an assignment is worth more than X percentage of your grade, it's not allowed to be due inside of the exam exclusionary period. So I'm going to have to look up, see what that exact percentage is, and work out the maths. So we'll see how it goes. But certainly, if not, I'll probably give you guys as close to, it's sort of Price is Right rules, close to, but not going over the last day that you're allowed to submit things. So, C++ may be considered a superset of C. If you think about it in terms of set theory, if the syntax of C is a set, the syntax of C++ is a superset of that set. That is to say, C++ syntax includes just about everything that is inside of C. There are a couple of exclusions, which, are abstract and arbitrary, but for the most part, everything that we've studied in C so far is applicable to C++. In general, they share the same basic syntax, so inside of a C++ program, you will have all kinds of include statements at the top of it. You will have a main function. The main function is where the execution starts in a C++ program, and you'll have defined a number of functions inside of a C++ program. The main difference is that C++ offers you many more useful and interesting manners of organizing the various functions and data that you are putting into your program, to make it so that you can more easily deal with larger programs, because we're working with higher levels of abstraction. Almost all of C's operators and keywords are present in C++ with unchanged semantics. So plus works the same, minus works the same, modulo works the same, increment, decrement work the same, but bitwise operators work the same. You've got while loops, you've got for loops, you've got if statements, you've got switch cases, you've got do whiles, you've got all of that stuff. All of that is in C++. The memory model is also largely the same, as are functions, scoping, and variables. So when I'm talking about the memory model, I'm talking about pointers. So pointers work in C++ in pretty much the exact same way as they work in C. It's, again, the differences will be quality of life improvements. C++ programs are structured, compiled, and executed highly similarly to C programs. The main differences are that C++ supports object-oriented programming via the inclusion of classes. So that's the big difference. C++ is an object-oriented programming language, but C is not. C is a procedural programming language. It does not include objects, it does not include classes. Some people like to very technically say that C++ is technically a hybrid language between the procedural paradigm and the object-oriented paradigm, because it's sort of, you take this procedural layout of C and then you layer on top of it all of the sort of object-oriented bric-a-brac that provide object-oriented functionality. But, this is, largely an academic distinction. Most object-oriented programming languages, if you removed the object-oriented stuff from them, would be procedural languages underneath. And I'm thinking of you, Python and Java. The other thing that you get in C++, notably, is exception handling, which is not something that you get in C, as we saw. I have a question. So does this mean I could copy-paste a C program into C++ and it would work? Well, probably. Let's take a look. Let's write ourselves a quick little C program. Get it, hello.c. Include standard io.h. Int main. Printf. Hello world. So this is a C program. So, obviously, if we compile it with GCC, and we execute that... Oh, I forgot the friggin' new line character. It gets me every time. There we go, we get hello world. So, the C++ compiler is G++. Now, you're still using the GNU compiler collection. This is just, this is GCC, but specifically for C++. You can actually compile C++ programs with a GCC invocation, but you need to set certain flags because the GCC does not link to the C++ standard library by default. You have to manually link to the C++ standard library. So all G++ is really is it's GCC with those C++ library inclusions. So there you go. G++ compiles hello.c, and there it goes. So for this example, this is both a valid C program and a valid C++ program, to answer your question. So in terms of like practical, in practical terms for you, a student of both C and C++ at this point, this does mean that if you don't know how to do something in C++ and you make recourse to your knowledge of C, that will normally work. As long as, you know, you're using everything in C++ the way that, as long as it's still, you know, syntactically valid C++ code. You know, that's why it's really important to think of all of the things that we are introducing with C++ as quality of life improvements over C. Once, it's kind of like, sure, you could do everything in C that you do in C++. Fundamentally, both languages compile down to assembly code, right? And any assembly program can be represented by a C program. So, any C++ program can be represented by a C program. That is just true. That's true of many languages. That's actually what it means for a language to be Turing complete, is that that language can express any other program that's written in any other Turing complete language. The question is, how convenient is it to do so? So there are many constructs that we're going to see, so to speak, in C++ that they make life easier if you learn how to use them. However, you know, there'll be some conceptual hurdles to get over to learn how to use them. So, yeah, anyway. So that's kind of how C relates to C++. So we're not starting from zero here. It's not like we're learning Haskell or something where we have to throw out everything we know about programming so far. We are building on our C knowledge. But, you know, that being said, a lot of the sort of abstractions that you have to do to be able to understand C++ code, they're going to look strange, and you might not get them at first. It's sort of, you gotta study it, you gotta practice it in order to really, you know, get into it. So anyway, so we just showed you Hello World in C. This is what Hello World looks like in C++ more strictly. That is to say, using C++'s library. So, rather than including stdio.h, we are including iostream, and we are making reference to the cout iostream object. And this guy here is the stream insertion operator. So, this is actually a lot more convenient than printfs, and you're going to see why. So, to convert our this program into a proper C++, well, actually, do I have this in this directory? Let's see here. Yeah, get it. hello.cpp. There we go. So if we want to compile that, g++ hello.cpp. There we go, and then we a.out that. Hello world. Good. So it does the same thing, essentially. So yeah. So this is a stream object. Let's see, am I jumping ahead? Yeah, I'm jumping ahead of the slides a little bit, but so this guy right here is a scope resolution operator, and this is something we're going to talk about in a reasonable degree of depth when we talk about overloading, or actually we'll be talking about namespaces, which is another concept in C++. But for now, think of it this way. In C++, stuff is organized into boxes, and those boxes are called namespaces. They work pretty similarly to the idea of scoping around functions, except it's like being able to abstract the idea of scoping and no longer have it apply specifically to functions. You can apply a scope to a series of functions, and in order to access things inside of a specific scope, you have to give you the name of that namespace, the scope resolution operator, and then the thing inside of that scope that you're trying to access. In this case, c.out, which is the C++ equivalent of the standard output file that you write stuff to, that printf writes stuff to. So, the stream insertion operator takes whatever this thing is, takes the second operand, and plugs that into the stream cout. So, since cout is hooked up to standard output, which is your operating system's output file, then this gets written eventually to standard output and appears on your screen. The cool thing about this is that we can chain together a bunch of things without having to worry too much about things. So, like, if we have int I is equal to 23, we can then chain I in there together, and then we can do stuff like that, and it's just so much quicker and easier than printf statements. You see how quickly I was able to do that? That was really fast. No more do we have to worry about mucking around with formatting tags in strings and multiple arguments to printf and having to write printf each time. Everything's a lot easier. So, I've kind of already showed you this, but in order to compile C++ programs with GCC, you need to use G++. Invoking GCC can work if you set certain flags. The C++ standard library isn't imported by default, but the GCC man page recommends using G++ instead. If the man page recommends it, that's a good recommendation. G++ usage is precisely the same as C, just using .cpp files instead of .c files. So the usage that you're used to with GCC, that is perfectly applicable to G++ if that's how you've been compiling things. Once your code is compiled, you may also execute it in the manner in which you are currently accustomed. A C++ mode or plugin for your favorite IDE should be simple enough to find, if it isn't already pre-installed. So if you wanted to do C++ in VS Code, for example, it is entirely probable that you got C++ at the same time that you got C. Normally, C and C++ compilers are packaged together. So you might even already have it. But it should be a reasonably simple thing to be able to have a C++ mode on whatever compiler you're using. Cool. It might even be just as simple as opening up a file with a .cpp extension a good IDE will just automatically switch the compiler to whatever compiler is the correct one for the file extension that you're operating on. So, let's talk about these crazy new symbols. Whereas in C, you write output to your system's standard output file, in C++, you send characters to the standard output stream. The stream itself is called cout and is located within the standard namespace. std is not, that is not, this isn't a health class. When we say std, we mean standard, as in standard input or standard output. This is why the .scope the 2:scope resolution operator is necessary to find it, because you have the global namespace, which doesn't really contain anything unless you've put it there, and then you have the standard namespace, which contains all of your library functions. The stream insertion operator is used to put elements into the stream. You can chain multiple insertions together in one line, and there's also a stream extraction operator, which is 2 arrows in the opposite direction, for taking inputs from streams, which we're about to see. So here is a C++ program, which I think I have here. Interact.cpp. So, we ask the user to enter a number by writing enter a number to cout. We then declare an integer. Standard cin is then x is extracted from cin. Cin is, of course, your C++ equivalent of standard input. Enter another slightly more complicated number. Same procedure. X equals x plus y. The sum of your two numbers is x. You can also just directly put expressions inside of here. It will resolve the expressions and perform the thing that you expect it to. So let's G++ this bad boy. And executor. Enter a number, 5. Enter another slightly more complicated number, 92. The sum of your numbers is 97. There we go. So, cool. That's how you take input. An interesting thing, though. So, I noticed this. If you enter multiple things on one of these lines, it passes it to the next iteration. So when you extract something from the stream, you're not clearing the stream buffer completely. You're just taking the first element out of that stream. So with the when you take one thing out of the stream here, you've got, that takes 64. When you take a second thing out of the stream down here, 924 has already been entered. So, it only waits for input if no input has been received. So, that gets assigned to y. Automatically, you don't have to enter the number. So the sum of your numbers is 988. There we go. Question. What does endl mean? Good question. That's actually on the next slide. I think maybe, yeah. So, to answer your question, std endl stands for endline. So this is endline. It does two things. Number one, it inserts the new line character. And number two, it flushes the output buffer. Now, we haven't really had to worry too much about flushing buffers before this point, but this business here with the inputs being taken when you enter more things in the line than perhaps you should have, that is the reason that that worked is because the input buffer was not flushed between those two requests for input. So the endline flushes the standard output buffer so that anything that's waiting to be printed gets printed at that point in time. It's like, okay, push that through. It's actually the case that some operating systems will wait until they've accumulated a certain amount of data inside of a buffer before actually sending that buffer information onto whatever it's being sent onto. So that's what a flush operation is. So hopefully that answers your question. Similarly to standard cout for outputs, we have standard cin for inputs. To extract data from the input stream, we use the sort of greater than operator and specify the destination variable. In C, we had to manually specify a format using formatting tags. Not so with C++. The data is automatically formatted to the data type of the container variable. You don't have to manually hook up the data type to the formatting tag and get both of those correct. It just does it. Again, this is what I'm talking about when I'm talking about quality of life improvement. Cool. So much for our introduction. So what are we going to talk about here? Over the next few sections, we're going to talk about various advanced topics in programming and how they are used in C++. When I say advanced topics in programming, I'm talking object-oriented concepts. These will include overloading, classes, inheritance, and polymorphism. Overloading and polymorphism are different things, by the way. So, let's talk about overloading. In computer science, overloading is the idea that a function or an operator can be given more than one type signature, and that the function or operator may execute code based on what type signature is used, or may execute different code depending on which type signature is used. We're actually already familiar with this idea from Python. So in Python, if you use the addition operator on two integers, it just adds them. But if you use the plus operator on two string, well, it works on strings too. If you use it on two lists, what you end up doing is concatenating those lists. So in this example, the plus operator is interpreted differently depending on what the type of the operands is. When we apply it to integers, yeah, that's what I said. So, we can do the same thing in C++. So this is overloading functions. We're going to get into overloading operators when we talk about classes, because it integrates into classes in a way that's, it's more smooth when we talk about classes. So, in C++, here is a program. I believe I have this one in here too. Get it? Overloading. .cpp. So, we've got, these are function declarations. They were just, they were made compact for the purpose of fitting them on the slide. But, just like C, C++ does not actually have any strict requirements with respect to white space, so you can put a whole function on one line if you really want to. Just like these variable declarations. So, we have type of. Type of is a function that returns a string. If the argument is an integer, it returns integer. If it returns a float, it returns floating point, and if it is a bool, it returns boolean as strings. We have three variables here, x, y, and z, which are int, float, and bool respectively, and to cout, we are writing x is a, and then whatever the return result of type of is. Type of is being called on x, y, and z. So, if we execute this, compile it first, of course, overloading.cpp, execute, you will see x is an integer, y is a floating point, and z is a boolean. So, what's happening here is that C++, when you execute the function, it's saying, okay, I have a function that is being given a Boolean argument. Do I have a definition of this function that takes one Boolean argument? And then it's like, oh, here it is. I do have a definition here. I'll go with that one. So, this means that you can have multiple function definitions that define functions that have the same name, essentially. What it is, sort of in abstract mathematical terms, is it's a decoupling of function names from type signatures, although they're still reasonably coupled. So, the output, there we go. It is as simple as defining a function multiple times with different type signatures. When executing, C++ will automatically select the function that matches the arguments it's called with. This is called overload resolution. That's a process that the compiler goes through, is overload resolution. Overloading should be used whenever you have to write multiple versions of a function for multiple argument types. So, in this example, we're returning different strings based on different data types. If you think back to void pointers in C, what would often happen is we would have something returned with a more generic data type, and then we would cast that into something more specific and then use it. This is a way of avoiding having generic data types while still maintaining that level of sort of resolution. Yeah, anyway, so there you go. Any questions about any of that? No? Well, let's talk about some sneakily introduced concepts in this example. Number one. Come on. There we go. Number one, using namespace standard. In previous examples, we used the scope resolution operator to access cout, which is located within the standard namespace. With this line, we set the whole program inside the standard namespace, so we no longer have to prepend standard : to all of our stream objects. Notice that we're just using cout here. We're not using std cout. However, if you did that, it would still work. That doesn't actually break the thing. That's because these objects can be accessed with either absolute or relative addressing. Just like a file in your file system may be accessed using either absolute or relative addressing. It's both of those work. It's just a matter of why would you do that if you went to the trouble of establishing that we're using the standard namespace. So, according to the GCC documentation, it is a standard requirement that all library components are kept in the standard namespace. And we're going to talk about namespaces. The other thing to notice here is that string and bool are just things now. In C, booleans are, you have to import standard boolean in order to have booleans available. And that inclusion in C is one of the things from C++ that went back and influenced the language that it was derived from, just like how C originally didn't have single-line comments. That was an addition that C++ made that they then went back and added to C. String is another interesting one. String is not quite the same thing as a character array. It's like a character array that you don't have to worry about the size of. So the interesting thing about that, though, is that strings are also contained in the standard namespace. So if we're no longer using the standard namespace, then we get all of these compiler errors. String does not name a type. Did you mean std in? So string does not exist. In order to, well, it doesn't exist in sort of global namespace. In order to access it, you'd have to prepend it with the standard. You'd have to go through standard to get it anyway, which, makes a fairly strong argument for including standard namespace. Notice we no longer have a error on where is it? Did I save that? There we go. Yeah, notice we no longer have an error on line 4. So in using the this line just saves you a lot of typing. So I recommend including it whenever you write a C++ program. Cool. So, the next topic is a little bit of a topic, so maybe I will wait now to see if you guys have any questions about what we've covered so far. And if you don't, then I think we will break for the weekend. Woo! Weekend, weekend. Everybody loves the weekend. Yeah. Anthony says, it seems like so far C++ is just C with a bit of plus. Yes, we're not... we haven't jumped off the deep end yet, though. One of the things that intimidates people with C++ is that, unless you understand the concept of namespace, you'll see these namespace operators, all over the place. And, there's also, specific stuff related to classes, like consideration of public and private members, and, there is a lot of stuff. But in general, yeah, that's not a bad way of thinking about it so far. Again, C++ is the next version of C. It intentionally kept the overwhelming majority of the things that are in C. So, yeah. Let me put it to you this way. I am glad that I'm glad that we learned C first and now we're doing a bit of C++, rather than doing that in reverse order. It seems to me that, anybody who takes a C++ course should have taken a C course first, because things will just work a lot better that way. But yeah, generally speaking, I would say that's a good observation. Okay. Seems like nobody has any questions, so have a good weekend, folks. I'll talk to you guys on Tuesday.